In this video, I'm going to show you how to find the domain of radical and rational functions. First, we'll start by solving f of x equals square root of x plus 5. I'm going to start off by writing x plus 5 is greater than or equal to 0. Since we have an even index number, we know that there are going to be some restrictions. So to solve for x, subtract 5 from both sides, leaving us with x is greater than or equal to negative 5. If we put this on the number line, we will have a closed circle at negative 5 because x can be greater than or equal to negative 5. And then we're going to draw an arrow towards the right, since again, x is greater than or equal to negative 5. So when we write this in interval notation, we'll have square brackets. Just brackets, since that is what a closed circle is associated with. And your domain will be that. So let's try another one. Next we have 1 over square root of x minus 7. We will set the radical greater than 0 because it is on the bottom. But if it were on the top, then it would be greater than or equal to 0. Now we will add 7 to both sides, indicating x is greater than 7. And when we draw a number line, you have an open circle at 7, and your arrow will be going to the right since x is greater than 7. And when you write your domain, you have parentheses, since that is what an open circle is associated with. Next problem, we have f of x equals 1 over x plus 5. So if we write x plus 5 equals 0 and solve for x, we get x equals negative 5. X cannot equal negative 5, which is because the number cannot equal 0. Well, the denominator cannot be 0. Now, I'll draw the number line, and over negative 5, we'll have an open circle, which indicates not inclusive, and the arrows will be going left and right from negative 5, telling us that the number can be either greater than negative 5 or less than. So interval notation, the domain, we'll use parentheses. So it'll be negative infinity to negative 5, union negative 5 to infinity, positive infinity. And that tells us the point of discontinuity too, which is at negative 5. For the next problem, we have f of x equals 8 over x minus 3. Oop, that's 2. Sorry. X minus 2, and then x plus 1. So first, you want to set both x minus 2 and x plus 1 equal to 0. So when we do x minus 2 equals 0, you get x cannot equal 2. And then x plus 1 equals 0, you get x cannot equal negative 1. Now I'll draw the number line, labeling negative 1 and positive 2. And both will have an open circle. And again, we have the green, which indicates that x can be any number that isn't negative 1 or positive 2. So it can be any number that is less than negative 1, between negative 1 and 2, or greater than 2. In an interval notation, the domain will be written with the use of parentheses, negative infinity to negative 1, union negative 1 to 2, union 2 to positive infinity. Next, we have f of x equals the square root of 7 minus x. Then we'll write that out as 7 minus x is greater than or equal to 0. And solving for x, you get 7 is greater than or equal to x. Now for the number line, we'll write it out labeling 0 and 7. And above the 7, you will have a closed dot or circle with an arrow going towards the left. And in interval notation, we have the domain written as negative infinity to 7 with a bracket, because again, the closed dot is associated with the bracket. All right, and for our final problem, we have 7 of x equals square root of x squared plus x minus 6. And first, we'll start by factoring it out underneath the square root. So the two numbers that gives us 6 are 2 and 3. You rewrite that as square root of x plus 3 and x minus 2. And then we'll set both sets equal to 0. And you get x cannot equal negative 3. And for the second set, you get x cannot equal positive 2. And then we draw our number line, labeling negative 3 and 2 on the number line with a closed circle. And then each of the spaces, I'm going to draw a green line because that indicates that you can have a number that is less than 3, between negative 3 and 2, or greater than 2. So we're in an interval notation. You have negative infinity to negative 3 with the bracket union 2 to infinity. And that is your answer.